All right, guys, welcome to another episode of Cuda Education. Today we're talking about the Vulkan API switching family queues. Now, if you're new to the Cuda Education series, the first thing you need to know is that I believe that in order to learn the Vulkan API, you need to have code running on your machine. So, if you want to have code running on your machine and you want to be able to run examples of projects running on your machine, you need to get these two tutorials. Tutorial number one is installing the Vulkan API itself on your Windows-based machine. Windows-based machine with a Vulkan-capable GPU. So tutorial number one is installing the Vulkan API. Tutorial number 13 is installing a series of Vulkan API examples. So the particular example we're going to use today, ComputeCloth.cpp, is basically a sphere with a cloth with the Vulkan logo on it dropping over the sphere. That's it. And then, you know, as the cloth drops over the sphere, the cloth adjusts and it hangs over the sphere, and then you could simulate wind. So you press the simulate wind button, and the cloth moves because it is being affected by wind. But I'd like you guys to follow along in these discussions. You know, I don't like this idea of just reading the spec or just looking at the book or whatever. You need to have code running on your machine and being able to manipulate that code in order to follow along and understand what I'm doing. So that's my spiel on getting up to speed. Today we're going to talk about, really quickly, we're going to talk about acquire and release, or in the order that I prefer, it's release and acquire. So queue families is the way how Vulkan works is it has these families of work, or families of methods, or families of doing stuff. You have the graphics queue family, you have the compute queue family, you also have a transfer queue family, and I think there's a binary queue family. On older GPUs, the graphics queue family and the compute queue family are separate and distinct. Okay, so it's two separate queue families. On more modern GPUs, the presentation, or the graphics and the compute queue family, is the same queue family. Don't ask me why this is. Don't ask me, you know, why they were separate in the first place. All that stuff. But just understand that Vulkan is not just a graphics engine. It's not just a computer graphics thing. You could also use Vulkan purely for compute purposes, so to take advantage of parallel processing on your GPU. But I digress. All right, so we have this ComputeCloth.cpp algorithm that is freely available. It's on GitHub, and I'll provide a link below for that algorithm. You will install this on tutorial number 13. You know, as part of the process, you will install this algorithm, and you will actually have it running on your machine. So again, real quickly, it's a globe, right, with a cloth basically descending down. Forgive me for my graphics, but basically it descends over the globe and adjusts accordingly with the globe. I think I sample it in one of my videos, freely available YouTube videos, where I show you the examples that I installed. But basically, that's the algorithm. As part of that thing, you're gonna have to present stuff. So you have to present the cloth descending. You're also gonna have to compute stuff. So you're gonna have to compute the effect of gravity on the cloth, the effect of the cloth hitting the sphere and adjusting. You're gonna have to compute the effects of wind, all that stuff. So we have a situation where we have graphics and we have compute tasks that we have to do, and we have to switch between the two. Now in the compute cloth algorithm, you do have there's a special flag that is used, or that is that is tested on the algorithm to test your GPU to find out is the graphics and compute Q family is the same Q family. If it is the same Q family, the specialized Q flag is turned off, because you don't make a distinction between graphics and compute. If it is separate Q families, though, if it's two separate things, the specialized Q flag is turned on, and then in the algorithm it has, if the flag is turned on, you're gonna have to manage switching. So that's what these functions are in the algorithm. You have add graphics to compute barrier. So basically you're switching from graphics to compute. Add compute to graphics barriers. You're switching from compute back to graphics. And then you have compute to compute, which I haven't actually, I should have investigated before the video, but I think that's just like a dummy release or something, because Vulkan complains about, you have to release something before you can acquire it. So that's pretty much how the general algorithm works as it relates to switching Q families, okay? Now there's a separate concept that we have to discuss. Within the algorithm, you have something called, and I'll just do this real quick. So you have like a VK buffer memory barrier, and for shorthand, I'm just gonna say this variable is BB, right? Okay. That's just for shorthand. Okay, so in that variable now of type VK memory buffer barrier, you have BB dot src Q family index. Okay, and you're gonna say it's equal to a whole bunch of stuff, like it's it's one thing, and then you concatenate to another thing, extension, but basically you go to graphics. Okay, all right, then you have bb dot dst Q family index equals a whole bunch of stuff, but then this is compute. Okay, now the important thing that you have to realize is that if the source, well, first of all, notice that there's a source and there's a destination. Okay, so the source is graphics, the destination is compute. So this I believe is depending on, you're basically moving over to compute, right? So the source is graphics and your destination is compute. Remember, we're talking about release and acquire, right? So the thing about it is that if, and maybe I'll just do it over here. Okay, because then you guys could see. All right, so if your source does not equal your destination, then you have certain considerations. If your source matches your current Q family, so you're running through this code, and when you execute this thing, you're already in the, say for example, the graphics Q family, right? So let's say the source is the current Q family. What this will boil down to is a release operation. So this will be a release operation. okay? And the reason it's a release operation is because your source family queue matches the current family queue that you're in. So you're currently in the graphics family queue and you're running this piece of code right here. And when the source family queue matches the current family queue that you're running your code in, that you already are in, then this boils down to a release operation. So this, I mean, it's a small snippet of what we're talking about, but this would basically sum up to being a release operation. So you're releasing this from the graphics family queue, okay? But not only do we release, we also have to acquire. Now, let's do it again. You have src does not equal dst, okay? But now your current family queue is, your current family queue now is the destination. So let's say you're running this code and now you are in the compute family queue. You're in the compute family queue and you're running this code. Because of this arrangement right here where the destination matches the current family queue that you're in, this will boil down to an acquire. Uh-oh, that's messy. This will boil down to an acquire operation, okay? So now this is a situation where acquire operation. So now what you're doing is you're acquiring basically the thread or the work for compute purposes. So there's a release operation and there's an acquire operation. So, and it's basically the same thing, but it depends now on you know what state is your code in. Are you already in the graphics family queue or are you already in the compute family queue? If you're in the graphics family queue, this boils down to a release operation because your source matches the current family queue, which is graphics. If it's if you're in the compute family queue and you run this, the destination matches the current family queue, so you're in an acquire operation. Either way, release or acquire, when you have these parameters right here, you are moving from graphics and you're switching from graphics to compute. Okay? And this is all within computecloth.cpp that is freely available on GitHub. You could just search for this string right here. Don't search for BB because I just use that for shorthand. But you could search for this or you could search for this. You could search for, this would be add graphics to, this would be add graphics to compute barriers. So this particular situation is add graphics to compute barriers. Now, right? And we're adding graphics to compute. So we're basically going from graphics and switching over to compute. Now, real quick, I don't want to make this video too long, but remember now, I could also switch these things. So I could make this now compute and make this graphics. Right? Now if I do this, regardless of the arrangement, whether I'm in compute or graphics, this basically is moving from compute family queue to graphics family queue. And this right here is the add compute to graphics barriers function, right? Because now you're moving from compute and you're going back to the graphics family queue. And again, you're either doing a release or acquire operation depending on what you're doing. So initially, you're probably in the graphics family queue, and then you're doing this thing. So if you're in the graphics family, no, you're probably in the compute family queue, and you're doing this thing. So this boils down to a release because you're releasing the compute because it matches the source, right? It matches the current family queue matches the source, and then when you run it again for when you're in the graphics family queue, you're releasing it from graphics, because the destination family queue matches I'm sorry. I'm sorry. When you're in the graphics now, you're in an acquire operation because the destination matches this, so you're in acquire. So you have to release and then you acquire. The thing about it is that in the code, the author of the code basically said that Vulkan complains about you trying to acquire something that hasn't explicitly been released. So the first thing he does, like this dummy release, which I'm not sure if that's what the add compute to compute barriers is, because I need to, I'll do that for another video. But basically he says that Vulkan complains about, you know, doing an acquire without a release. So you kind of have to release first before you acquire, even if nothing is necessarily have it or whatever, but you have to release. So that's why I do release and acquire. I don't do acquire and release. I do release first and acquire, because in the code you release first and then you acquire. Anyway, that's the lesson for today. Remember guys, tutorial number 1 and tutorial number 13. I want you guys to follow along. Vulkan is the future, OpenGL is the past. You know, we're going to holograms, we're going to simulation, military simulations. Obviously, you guys love video games and all that stuff. This is the raw material of stuff in order for you to design your own game and make it customized and do exactly what you want. This is not some high-level tool where, you know, you're just putting objects together on some kind of, you know, platform or something and you're trying to make a game. No, this is the heart of computer graphics. So it's gonna be the future. Everyone is remote working now. It's gonna become more and more of a thing. So start learning now. Tutorial number 1, tutorial number 13. You could get both of them for less than the cost of Starbucks coffee. Windows-based machine, Vulkan capable GPU. Just as a little thing, I have a 1050 Ti, GTX 1050 Ti. The graphics and compute family queue is the same, so I can run it with the specialized flag turn off. But even when I disable, even when I turn on the flag and I force the code to go it through having distinct graphics and compute families and having to switch between the two, the code still works. So, you know, it doesn't matter for me. But depending on the GPU that you have, you might have separate family queues for what you're doing. Remember, you have graphics family queue, compute family queue, which sometimes could be the same or different family queues. You also have transfer family queue, and I think a binary family queue, which I know nothing about. But that's it, guys. Thank you for watching another video. I look forward to seeing you guys again. I'm gonna make some more videos about this topic, but this is just a small piece of the switching family queues puzzle, but it's a start. Have a good day.